So we gain like an overview about OSI and basics of network and network cables and network devices. In OSI, we discussed the different kind of layers. What you could hear about a lot in this case could be when you hear about layer 2, which indicates that you are dealing in data link layer, which use MAC address in order to allow communication between devices inside the internal network. But although that inside internal network we need MAC address to communicate, that does not prevent or deny the need for having IP address as well, because we understood that it works as a stack. You should place something inside other things. So you cannot take the data and inside the layer 3 header or IP header. You should have layer 4 in between. And the same situation, you cannot send the layer 3 packet in the network without inserting it inside a frame, which is a layer 2 header. So layer 2 header is also another name for data link layer header, and it defines who is the MAC address that I want to try to communicate. MAC address is a kind of device addressing, and the MAC address differentiate who could be the vendor of a certain network device or a certain network port, and what is the serial number of this network interface card. We can find that MAC address can be, you can get the MAC address of your Windows device by writing the command of getMAC. So getMAC will show you the possible network interfaces that are on your device and what is the MAC address linked or assigned to each one of these interfaces. So we can see that the MAC address of these two network interfaces is similar in regard to the first three parts, because the first three parts in any MAC address define the organizational unique identifier or the name of the vendor that have this MAC address or created this network interface. We have many vendors that could be creating a network interface card, such as Intel, HP, Dell, Microsoft, Samsung. All of these are name of vendors that could be creating network devices or network interfaces, network ports. Even your mobile phone, it includes like a chipset, and this chipset is responsible for making you connected to the Wi-Fi. So it is a network interface, by the way. So this network interface should have a MAC address as well, because if it don't have a MAC address, you will not be allowed to communicate inside the local network. So by getting the MAC address of any device, you can get this MAC address and go to the internet and look for a tool that do a kind of MAC address check. So by using a tool such as this one, for example, you can type the MAC address that you got from a particular device, and then you can click search. It can tell you that who is the manufacturer who creates this MAC address, or what is the manufacturer who has this MAC address, or who can assign these first three parts to any network interface that he can create. So based on this, I can do a kind, for example, if I want to detect the man in the middle attack, which we described yesterday, based on the ARP information of the network, I can identify what is the different MAC addresses inside the network that I am currently at. And based on this, I can do a check for all of these MAC addresses to identify who is the manufacturer or who is the vendor that created this particular network interface card. And if I used to have Dell devices, Dell or HP devices in my network, in case I found another device that is related to Huawei, for example, this could be an issue, because it is not usually to have a device that was created by Huawei in my own internal network. Clear? So based on MAC address, you can identify who is the vendor that created this network interface card. And by the way, MAC address is consisted from two parts. The first part is defining the vendor, and second part is defining like the serial number of this particular network interface card. And the MAC address by default is a static address, which means if I took my own laptop and came to your own network and connected my device to your own network, the MAC address will be still the same, because it is a burned-in address, which means he is configured or hard-coded in the network interface card itself. While the IP address is not the same. IP address is called a static, a logical address. If I am staying at my home network, I could have an IP address from the range of my home network, like 192.168.1.1. But if I go to my office network could use different IP networks, such as 10.10.1.1. So depending on where I'm at, I will take a different address in case of IP address or layer 3 address. That's why layer 3 address is known as logical address, while MAC address is known as physical address. Fine? So when we look to how MAC addresses are written, we will find that MAC address is written in a very strange way, right? We will can find that he is consisted of like 6 pieces. If every piece include like 2 characters, these characters could be something between 0 and 9 or A and F. Can someone tells me what this numbering system is? What is the numbering system that can use 0 to 9 and A to F only? Okay, what do we mean by numbering system? The way that we can represent the numbers. So we have a very famous numbering system that we use right now. Yeah, it is hexadecimal, right? We have what is called the decimal numbering. And decimal numbering means that we can use 1, 2, 3, 4, 5, 10. And once we reach 10, we can remove the 0 and add 1. So it will become 11, 12, 13, 14, 15, and so on, right? This is known as decimal. But when I ask you to represent the value of 10 trillion in decimal way, it could be somehow hard because you will need to take care about writing 1, 10, and that's you need to add, I believe, 3 zeros, and then 3, and then 3, and then other 3, and that's, I believe, that's a billion. So I believe we need to add like this could be $10 trillion or 10 trillion as a value. So they need to figure a way to reduce the amount of spaces required to describe a certain number. So that's why they come with a different formats, such as the binary. In binary we can refer to data by 0 and 1. But the problem is if I want to represent decimal value of 10 trillion in binary, it could create a larger value than the value that could be created using the decimal way. As a result, they wanted to develop a new numbering system that could reduce the amount of letters needed to represent a certain value. And this example or this numbering system could be the hexadecimal. Hexadecimal is a way in writing that allow you for these 2 characters to represent 16 bits of data, which means these 2 values can represent a number up to 65,536. So instead of writing this value in a decimal way, I can write these 2 values only, and it will indicate the same value that we are seeing now on the screen. How does it happen? Some equation somewhere in writing that make this value in hexadecimal equivalent to this value in decimal. To make it clear or to test it by yourself, you can open the calculator of your Windows. You can select the programmer mode, and you can write the value in hex of FF. And then check how much does it equal in decimal. I believe it is not FF. I'm sorry. I'm so sorry. FF equal 250. No, not 65,000 and all of this stuff. Okay. So I believe FFF is what 4Fs it is what equal to this number. So as you can see, if I selected to write in hexadecimal way and written like 4Fs, that will result in decimal way like 65,535. So if I selected to write in a decimal format and I wrote the value of 10 trillion, which is a lot of zeros, it can be written in hexadecimal format in this way, which could be easy to remember or could be easy to written. Okay? So by writing a MAC address, and of course we have billions of network devices across the globe, and each one should have a unique address that differentiates this address from other devices inside the same network. So by writing the MAC address in a binary way, we can take this value and check what could this value indicate. It could indicate a number such as 1 trillion, 1 trillion and 1, 1 trillion and 2. But instead of giving your device a hardware address that is 1 trillion and 1, which could not be easy to remember, like saying 1 trillion and 100 million and, we define this value in an hexadecimal way. And hexadecimal way is just another numbering system that allow you to write numbers in more efficient way. Clear? So how FF could be, or how FF could be 255? Would you like to know how? Yeah, but let me relate it to other thing. The base computer language is what? Or the base numbering system that can be understood by Win computer is what? Decimal or binary or hexadecimal? Which is 0 and 1. So for Windows, we have the smallest sizing unit called the byte, right? And we read before in classes and something like this that byte is equal 8-bit. So the smallest sizing unit or smallest unit or unit that indicates size in Windows or in computer in general is the bit. Fine? So, and the bit, how much bits can equal 1 byte? 8. So we have these 8 zeros, which could indicate a single byte. Fine? So I believe it is 8, right? It is 8 or 9, 8. Yeah. So each one of these bytes have a value to either be 1 or either be 0. And each one of these bits, if we counted it in this order, have a value differ according to the location where this bit is. For example, this 0 is equal 1. This E0 is equal 2 from decimal perspective. This 0 is equal 4. This 0 is equal 8. This one equals 16. This one equal 32. This one equal 64. And this one equal 1 to 8. 128. These values here on top are fixed. In case I have in the binary system one placed in this area and one placed under this particular bit, the decimal value of all of this will be the total of 16 and 1. Why? Because I took the decimal value linked with the 1, but for the rest of values, it includes zeros, not 1. So when I saw a binary value such as this one, this would indicate the decimal value of 17. Let's try it together. We will open our calculator. And what I'm talking here is basics that could help you in anything other than cybersecurity as well. So let's try to write in binary. I will try to write, I believe, 0, 0, 0. This is binary. So I cannot write it here. So I can open my web browser and I can select a binary to decimal calculator. So I will open this application here and I will try to copy this data, which indicates the binary value, right? I assume that this value would equal to 17. So I need to remove the spaces. When I click convert, the value will be hot 17. How it comes? Because each 0 from the 8 bits here is mapped to a particular value. It is always 1, 2, 4, 8, 16, 32, 64, 128. And if we added another colon, it will be, let me give you here another hint. Yeah, double. Yeah, double and double. And so we'll go 256512, 1024, 2048. These numbers are fixed. If you can remember when I was discussing AES Advanced Encryption Standard, I told you that it uses a key of 128, not 127. The memory space or the size of RAM could be 4 or 8 or 16 or 32. I cannot find a memory chip that is like 30 gigabyte only, right? So it is all linked to each other. And at the end, based on the location of a particular bit, and by mapping it to associated number, I can define what could be the value of this binary data. If I have a binary data that all are in this way, that would indicate a total value of 256. And as we are counting 0 in our equation, so in reality, that's why in IP addresses, for example, we can have the maximum IP address that I can assign is 255. In reality, if you try to count all of this, it will give you a result not 255. It will give you 256. So why I can only insert an IP address of 255? Because 0 is counted already. So we start counting from 0. So 0 until 255 will equal 256. Okay? So how come this value could be equal to F? It is again another numbering system, which is called hexadecimal. In hexadecimal, we convert the binary data to another way for writing, which is called hexadecimal. So hexadecimal can be written in this way. In hexadecimal, I will try to, where is the Excel sheet? I will try to translate this data to a hexadecimal way. So all of this data here, if I reach it like the value of 16, this could result in F, which means, look again with me. In hexadecimal, the maximum size of a single character is not 0 or 1. It could be from 0 to F, while 0 indicates the decimal number of 0. 1 is 1, 2 is 2, until we go and reach the number of 9. But starting from 9, we instead of writing 10, we will write A. Instead of writing 11, we will write B. 12, C. 13, D. 14, E. And 15, F. Fine? So if we try to add 1 on all of these sectors, we will find the value is at the end, the total value will be, I believe, 16, or as we agreed, it is 15. So that's why when I have all of these bits filled by F, the total value of its binary or its decimal value will be 16, which can be represented instead of writing 1111, we can only write F. Make sense? And what about the next 4 bits? The next 4 bits, although this value should be mapped to 1, but as the location comes as the 5th one, so it does not, this one here does not equal 1, and this one does not equal 2. It equals 16 and 32 respectively. So the total value of this should be F as well, because from binary perspective, it is also 16. But the location of the next 4 bits here will indicate another completely new value. I know it's kind of hard and may be kind of complicated, but this is what do we mean by numbering system. Why MAC address is written in this way. It is at the end will be mapped to a decimal value. But instead of writing the decimal value in a way that could be hard, we can write it in a way that could be easy using numbers and characters as well. IPv4 is one of the addresses that are written in the binary system, but instead of writing it in a binary like 1010 and so on, we write it in a way called the dotted decimal. Dotted decimal means each IP address is segregated to 4 parts. Each part is segregated by a dot. And between every dot and each other, we will have a decimal value. This decimal value cannot exceed the value of 255. Why? Because in each section here, we have maximum of 8 bits. And these 8 bits, when we try to evaluate what is the possible values of decimal values that could be related to it, it can be only 255. Do you remember from the last table? So that's why IP address is called 32-bit addressing system, while the MAC address is called 48-bit addressing system. What do we mean here is the total possibilities of MAC address across the globe could be 48 or 2. Where it could be 2 power 48. So why 2? Because we have 2 options, either 0 or 1. Why it is 48? Because MAC address has 48 bit. So each bit in the MAC address could accept either 0 or 1. That's make this is the total available IP MAC addresses that can be used. It is, I believe, like 281 trillion. Okay? If we applied the same concept from respective to IP address, the IP address is 32-bit, which means we have like 4 billion possible results of IP addresses. I can get this by telling you that 2 power 32. So which should provide more address space? MAC address. But MAC address is used for LAN, while IP address is used for internet. Fine? Okay? Okay, so that's make IPv4 address for your info is the depleting. I think it is the right word, depleting. The IPv4 is depleting because we have like 4 billion and we have increasing number of smartphones, smart devices, and devices that are connected to the internet. That's why they are developing, or we already have in place, IPv6. IPv6 is 128 numbering system or 128-bit address system, which means we have like 2 power 128 available IPv6 address to be used. But by the time we are migrating from the IP address that's why we have techniques to make like a migration from IPv4 based system to IPv6. I bet all of us are still using IPv4 as the main IP addressing form. But by time, maybe after 20 years from now, 30 years from now, we can find that IPv6 address will be used and will be used in exchange of IPv4. So I believe we discussed what is the ARP protocol is. So ARP protocol help you to identify or do a kind of layer 2 to layer 3 address mapping. We agree with this. And we understood what is the relation between ARP and the man in the middle attack. So ARP provide information about the IP address mapping in relation to particular MAC address. And if hacker tried or managed to spoof the ARP information, he will be able to do an attack such as the man in the middle attack. Fine? Okay, we have here a question which is, what is the network? I know it could be a basic question, but as we mentioned before, we're trying to think together and provide possible answers. That's right. And what is the criteria that based on it, I define that they are group of devices that share resources together. We should have like a borders, a boundary, a criteria that tells that we are all in the same network. I maybe have 5 devices that are together at the same room, but they might not be at the same network, right? But I have the concept of VLAN, and in the concept of VLAN, I can logically separate devices connected to the same switch to different networks at the same time. So I can place a printer in a VLAN that take a certain IP address or a certain IP address from a certain range, and another devices that take IP address from a different range. So what do you think here? So in fact, network is group of devices that share same network ID, share the same IP address schema. For example, if I have IP address with IP address 10.1.1.1 and I have IP address 10.1.1.2, are they at the same network together? What if I told you 10.1.1.1 and 10.101 and 1? In fact, it could be yes and could be no, because I have a missing information here, which is what is the subnet mask? While we are configuring our computer devices, printers, and so on, if I am configuring it in a static way, I would be requested to enter both IP address and both subnet mask, right? So what is the subnet mask? Subnet mask is like a way that define what is the boundary of my network, who is considered part of my network and who is considered not part of my network. For example, at the end, we agreed this value is written with which numbering system? It is a binary, right? That's right. But what about this value exactly? It is at the end a decimal, but it can be translated back to a binary value. What could be the binary value of this 255? 8 ones. 1, 1, 1, 1, 1. Right? So, what we can do to answer my question, which is asking if 10.1.1.1 and 10.100.1.1 are in the same network or not, we should ask what is the subnet mask. So the subnet mask in this case, for example, is 10.55, 10.55, 10.55.0. So I will get the first IP address, which is 10.1.1.1, and I will get the second IP address. I will repeat this step here. I will just make it copy here. And I will set 10.100 and 1 and 1. And I will start in do a kind of analysis based on the IP addresses. I will do a process to convert this value back to the binary value and convert this value to its binary value. Can you get this? I know it is making complicated, but at the end, it is recorded, so we can refer back to this information. Okay? So how to convert this value to its binary value? We should write 128, right? 64, 32, 16, 8, 4, 2, 1, right? So 255 is equaling what? This part exactly. Is equaling 1, 1, 1, 1, 1, 1. What about 10? Which area or which fields here that I should add 1 to make the total value of this 10? So I will add 1 and 1. And the rest will be what? The process that I'm currently doing right now is known as XOR. XOR operation. In XOR operation, 0 with anything will equal 0. 1 with 1 will equal 1. So by do the XOR operation, I will get here 0, 1, 0, 1, 0, 0, 0, 0. Is there any comment? Clear? So the value of XOR operation between these two values here will equal 10. We don't need to repeat this step once again for this octet and this octet, or this part and this part, because everything has, or any octet that has 255 will be as it is. Fine? But for the last one, we don't have 55. So we may need to do the XOR process for this particular value. So for MAC address of 0, what does it equal? Right? And for 1? And when we do XOR for this value, what could be the result? When we see 0, it will equal 0. When we see 1 and 0, will equal 0. When we see 1 and 1, will equal 1. What could be the total value? That's right. So the value that you are currently see now on the screen is process done by the first device, which is 10.1.1.1, to get his own network ID. He used what to get this? He used the Mac, the Subnet Mask configured for his device. Fine? The same operation will be done for the next device. So anything with 0, we do not need to repeat this long step once again. Anything with 0 will equal 1, will equal what? I know it will equal 0 because I will transfer this value to binary, and will transfer this value to binary, and will do a process called XOR. By the way, the XOR is a mathematical operation that has this sign. This is the sign of XOR operation. You may find it in the algorithms or something like this. It could be something like this, I believe. This is the symbol of XOR. Okay? So at the end, it will be 10, and here the value will be what? And here? Yeah, so the network ID of the second IP address is totally different than the network ID of the first IP address. Network ID is the value that is responsible to tell the host if the destination adds the same network or not. If the value of network ID between me and you is different, then both of us will need a router in between us to communicate. We will need to ask the gateway to communicate with each other. Fine? What if I told you that the subnet mask in our situation was not 255.255.255.0. It was 255.0.0.0. The situation now will differ. Because in this situation, the network ID here will be 0, 0, right? And here will be also. As a result, the network ID will be the same. So we cannot say someone in the same network with other one until we got what? The subnet mask, which based on it, we will go to the same network ID. So I hope that is clear for you and make you more understand or give you more understanding about what is the subnet mask and why IP addresses are written in this way. By the way, when the traffic goes to the default gateway, when the device itself found that he need to communicate with someone that does not share with us the same network ID. So in this case, I should have a default gateway configured in my network settings. So I will go to this default gateway and will ask it to make me reach to this external subnet. Okay? So transport layer objective, as we mentioned earlier, something such as TCP protocol or UDP protocol are categorized as transport layer objectives. They help in segmenting the data to small pieces. They can help us to track the data and correct the error if found. For example, if I sent 100 million pieces of data, each one of it will be serialized with numbers. So if the receiving party missed or didn't receive this part, it can respond back to the sender to resend this part once again. Okay? And by the way, one of the protocols of TCP layer or transport layer is known as TCP. TCP is known as a connection-oriented protocol, and it used something called sequence number to record what he had sent. He used acknowledge way to ensure that the data delivered reaches the destination itself, and it can make more overhead over data. Remember when I was describing to you what is the layer 2 header? Could you please explain what is the layer 2 header? It is like the envelope, right? That I place the source MAC and destination MAC. Right? What is the layer 3 header or the IP header? It is another envelope that I can place inside it source IP address and destination IP address. What is the layer 4 header? It is yeah. I can add inside it source port and destination port address. But in fact, and in case in TCP, I need to add sequence number. So another overhead will be added here. I need to add a way to make the other one who receives the data inform me either he received the data or not, such as acknowledge. So in TCP, for example, we have something called the flags, and these flags design or define if we received the data or not. Shall we continue or shall we stop the communication? Am I ready to receive data from you or not? So TCP connection is known as three-way handshake communication because in TCP, whenever a side sends a certain data, the other side should respond by acknowledging the receive of this data, and then the sender or the client will respond with ACK. So for whatever data we are sharing with each others, I send you data, you respond that you received the data, and then I respond back and tells you that I know you knew that or you responded that you received the data. That's called the three-way handshake in TCP. And that's of course cause a network overload because for any image that I send you, I should send you first, and then you respond to me to confirm, and I send you back to say I confirm that you sent me a confirm. Could you imagine? But as a result for this, we can ensure more reliable delivery for data. We will ensure that data reached you correctly. But this type of protocol or transport header may be good in data, images, videos, photos, and so on. But what about voice over IP or real-time data, which does not have the option to resend what had been sent before? For example, in Zoom meetings or something like this, when I encounter network connectivity error, what I am currently saying will be lost because it is a connectionless. There will be no meaning that your Zoom application will send it to my application to resend what I just said few minutes or few seconds ago. So UDP is another transport header protocol, but it can be used only for data that does not require reliability, such as voice data. But it exists because I cannot add data inside IP packet directly. I should have kind of layer 4 header, which in this case could be what? The user datagram protocol, which can be used for data such as voice over IP. It makes less overhead because it does not require to send ACK, then ACK again, or does not require to have source port, destination port. In fact, it requires only to add source port and destination port alone. Okay, but it does not need to add acknowledgement, flags, and all of this stuff. So this could be less overhead. Assuming that you are sending me 1,500 of data, this data is not purely data, by the way. This should consider also the size of IP header and the size of transport header and the raw data inside all of these headers. So this size is not the data. It considers the layer 3 header and the layer 4 header as well. So TCP use more space while UDP does not. So in UDP message, I can send like 1,400 raw data, while in TCP, I can only send 1,300 of data, or 1,300 if we can say it in this way. Clear? Of course, there are a lot of information about both TCP and UDP, but that will do for the scope of our class. I believe we discussed this concept, which is the difference between secure and insecure protocols.